students. Okay, welcome to third semester syllabus. Okay, today I'll start third chemistry syllabus. First, I want to start the inorganic chemistry. In inorganic chemistry, okay, we have acid and bases. Last video I discussed about the acid and base. What is an acid? What is base? Okay, I gave some examples. Okay, here acid-base theories. Okay, the properties, the characteristics of an acid and bases can be explained by using these several theories. These are the important theories. Okay, actually first definition, fundamental definition of an acid given by Lavoisier. The chemical substance which contain oxygen, those only simply considered as an acid. But this theory failed to explain the acidic nature of hydrochloric acid. Hydrochloric acid doesn't contain oxygen, so this theory was failed. This is the first theory and Lavoisier's theory. After that, so many theories, try to explain the chemical properties, physical properties, properties, characteristics, and different examples given by some of the important theories. The important theories are: first one, Arrhenius acid-base theory, Lux flood theory, Bronsted-Lowry theory, acid-base theory, Lewis acid-base theory, Cadet-Easy theory, Ushanovich theory, Pearson's HSAB theory. HSAB concept we call as theory. HSAB, H means hard, S means soft, A means acid, base. HSAB concept. Hard, soft, acid, base concept. Hard, soft, acid, base concept. In continuation, here I wanted to discuss about the first theory, that is Arrhenius theory. Arrhenius acid-base theory. After that, we will see Lux flood theory and Bronsted-Lowry theory. First, acid-base theory, Arrhenius acid-base theory. According to the Arrhenius acid-base theory, the chemical substance which releases the H plus ion in aqueous solution. The chemical substance which releases the H plus ion in aqueous solution. Aqueous solution means water. Called as an acid. The chemical substance which releases the H plus ion in aqueous medium or in aqueous solution or in water, we called as an acid. The chemical substance which releases the OH minus ion in aqueous solution or in water, aqueous medium, we called as base. What is the base? The chemical substance which releases the OH minus ion in aqueous medium, we simply called as base. Example for Arrhenius acid. So many examples are there for Arrhenius acid: hydrochloric acid, sulfuric acid, sulfurous acid, phosphoric acid, H3PO4, phosphorus acid, H3PO3. Here HNO3, nitric acid. All these are nitric acid. HCl, HOCl or HClO4, HOCl. This is perchloric acid. This is hypochlorous acid. HClO2, chlorous acid. HClO3, chloric acid. Chloric acid, nitric acid, nitrous acid. HNO2 we call as nitrous acid. So many acids are there. So many mineral acids. All those are gives H plus ion when these are dissolved in a water. Suppose for example hydrochloric acid is there. When hydrochloric acid, actually hydrochloric acid is a gas. Hydrogen chloride, okay, actually HCl is the hydrogen chloride. Hydrogen chloride. In gaseous state, it never gives the H plus ion. That means it never exhibits the acidic nature. Never exhibits the acidic nature. When it dissolved in a water, then we called hydrogen chloride solution. That hydrogen chloride solution we called as hydrochloric acid. That hydrogen chloride solution we called as hydrochloric acid. When hydrochloric acid dissolved in a water, what happens? It gives H plus ion, forms H3O plus ion and Cl minus. Okay, it releases H plus ion. That's why HCl is considered as a Arrhenius acid. Same like all use the H plus ion and form the hydronium ions here. Hydronium ion. Here also, see the examples for the bases. Okay, so many examples are there. Okay, all the hydroxides of first group elements, second group elements, some D block elements, all the hydroxides of first group elements, second group elements and some of the D block elements we considered as a base. Sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, okay, calcium hydroxide, okay, here beryllium hydroxide, aluminium hydroxide, aluminium hydroxide, magnesium hydroxide, strontium hydroxide, barium hydroxide, zinc hydroxide, okay, here cupric hydroxide, lead hydroxide, all those are the best examples for the bases. When these are dissolved, for example, sodium hydroxide dissolved in water, sodium hydroxide dissolved in water, it forms Na plus and here OH minus. We'll get here OH minus. Okay, here it gives OH minus ion due to liberation of OH minus ion. Due to the liberation of OH minus ion. Okay, sodium hydroxide is simply considered as a base. Simply considered as a base. Okay, here according to the Arrhenius acid and base theory, these are the examples for the acids and bases. Okay, see, then in conclusion we'll see the advantages. Okay, advantages of Arrhenius acid base theory. Advantages of Arrhenius acid base theory. Okay, first one, we have to identify the strength of the molecule, strength of the acid and base. Okay, based on the strength of that molecule, acids and bases classified into two types: strong acids, weak acids; strong bases, weak bases. That means, okay, based on the strength, acids can be classified into two types: strong acids, weak acids. Strong base, okay, here weak base. Strong base, weak base. What are the strong acids? What are the weak acids? What are the strong base? What are the weak base? Weak bases. Okay, the chemical substance which gives the H plus ion fastly we call strong acids. The chemical substances which gives the H plus ion fastly we called as strong acid. Example for strong acid, all mineral acids, H2SO4, hydrochloric acid, phosphoric acid, okay, here nitric acid, okay, here HClO4. All these are the important examples for the strong acid. Okay, weak acid means the chemical substance which gives the H plus ion in aqueous medium slowly. The chemical substance which releases the H plus ion, okay, in aqueous medium slowly we called as weak acid. All organic acids are weak acid. Acetic acid, CH3COH we called as acetic acid. HCOOH we called as formic acid. Okay, here This is also one of the important acid, oxalic acid. All these are the best examples for the weak acids. All these are the best examples for the weak acids. Strong base, okay, which gives, okay, the chemical substance which gives OH minus ion fastly. The chemical substance which gives OH minus ion fastly. Those are simply considered as a strong base. Example for strong base: first A group element hydroxides, second group element hydroxides is considered as strong base. Sodium hydroxide is a strong base, potassium hydroxide strong base, calcium hydroxide strong base, okay, magnesium hydroxide strong base, okay, zinc hydroxide also strong base. All these are the best examples for the strong bases. Okay, what is the weak base? What is the weak base? Okay, the chemical substance which gives the OH minus ion slowly. The chemical substance which gives the OH minus ion slowly, we called as weak base. Suppose for example, ammonium hydroxide. Ammonium hydroxide is the weak base. Okay, it gives OH minus ion slowly in aqueous medium. That's why it is simply considered as a weak base. Okay, by using this Arrhenius theory, we have to determine, we have to explain the strength of acid and base. Weak acid, strong base, weak base, like that. Okay, then in conclusion we see some more advantages. By using this, we have to explain the neutralization. What is the meaning of neutralization? When acid reacts with base, forms salt and water. When an acid reacts with, second advantage of this one, when acid reacts with base, what happens? We get salt, water. This we called as neutralization. This we called as neutralization reaction. Okay, Arrhenius theory mainly explains about the neutralization. How neutralization is possible here? When an acid reacts with base, form the salt and water. That's reaction we called as acid-base reaction or neutralization reaction. For example, you take a hydrochloric acid reacts with sodium hydroxide. What happens? We get here sodium chloride is a salt and water. This is the one neutralization reaction. And here, when an acid and base involves in neutralization reaction, some amount of heat was evolved. That we call as enthalpy of neutralization. When an acid reacts with base, forms salt, water. Along with that, some amount of heat was evolved. This heat we call as heat of neutralization or enthalpy of neutralization. Delta Hn. N means neutralization. Here, for strong acid, strong base, this should be minus 97.2 kilojoules per mole. Any strong acid and strong base. When strong acid and strong base involves in neutralization, the heat of neutralization is minus 97.2 kilojoules per mole. Minus here 13.6 kilocalories per mole. 13.6 kilocalories per mole. If acid, suppose for example, here I am taking sodium hydroxide plus hydrochloric acid. Here we get sodium chloride plus water. For this, heat of neutralization is minus 97.2. If instead of sodium hydroxide, if you take potassium hydroxide, instead of hydrochloric acid, if you take sulfuric acid, we will get only same type of heat of neutralization, same neutralization. Here we get same neutralization, heat of neutralization. If you take, here for example, strong acid, weak base. Here weak acid, strong base. Weak acid, weak base. If involves neutralization, here forms salt and water. water. But here, the heat of neutralization should be less than 97.2 kilojoules per mole, or here 13.6 kilocalories per mole. Less than these values. That means this explains about the heat of neutralization. And here, Arrhenius theory also explains about the acidic nature of non-metallic oxides in aqueous media. Acidic nature of non-metallic oxides like sulfur trioxide, nitrogen pentoxide, nitrogen pentoxide. So many are there. Phosphorus pentoxide. When sulfur dioxide, it is a oxide, non-metallic oxide. These are non-metallic oxides. When these are dissolved in a water, it shows acidic nature. Not dissolved means it not show the acidic nature. When sulfur trioxide dissolved in a water, it forms sulfuric acid. When nitrogen pentoxide dissolved in a water, forms nitric acid. When phosphorus pentoxide dissolved in a water, forms phosphoric acid. Here this theory explains about the nature, acidic nature of the non-metallic oxides like sulfur trioxide, nitrogen pentoxide, phosphorus pentoxide. Then in continuation, it also explains about the relative strengths of acid and bases. Relative strengths of an acid and base by using dissociation concept. Good morning.